So this is a walkthrough for an HDA that I've made called Chase. Let's create a new one. It takes 3 inputs and gives you 5 outputs. First one is your target. Second is your shooter. And what I did is I used this drone and I've added at the very end of the opening of the cannon, I added basically 2 spheres in here. And this is gonna be our emission sourcing. You get something like this. And for our ground collision, this ground, this grid that has some mountain remeshed and has mountain noise applied to it. So your target goes to the first input, the second one is your shooters, the third one is your collision, and the first output is going to be your bullets. All you have to do is select this null, come to the chase, under sourcing points, visualize points, and you get this circle around it that you can increase and you can delete points inside. I will use the same settings because I already cached all of the effects. This is all that I have to change because everything is depending on this the particle layer at the beginning, the particles layer. So you can uncheck visualize points, come to shooter, and this is asking you to define how many you get a strike every how many frames. So every 8 frames you get a strike, and each strike you can increase how many bullets, you can choose how many bullets per strike. Right now we are getting every 8 frames we are getting just 1 bullet per strike. So let's press play and you get this. You can increase number of points, number of bullets per strike. So now we get 2 for each. Let's just give it to 1. I'm adding noise so they don't have a straight line, and I'm delaying between points, basically between shots. Like if you made this 0.1 and I've decreased amplitude to 0 for the noise, then we'll get something like this. Reset simulation and save the disk. And in here also there is bullet shape. Once you visualize a bullet shape, you can play with its shape, you can reshape using very basic stuff, and you have also volumetric shape where it applies a temperature field to it, so you get your bullets to be has temperature field on it, like fire stuff. Anyways, comes to ground deforming. Let's just give it a geometric way. Coming to ground deforming, that's happening the second output. If you merged these together, you'll find that the ground deformation happening where the bullets hits, basically. So coming to ground deforming, visualize points, and I'm using the inside faces for the Voronoi as cutters for bullion fracture. So you can increase how many points around the center that's happening. So you need more fragments around the head center point area and as you move away towards the edges, you get less and less and more. You get less and less fragments. You can add interior details for the inside faces. And what is driving this deformation is two things. We are pushing down the pieces and we are rotating, applying rotation for each piece towards the center point. That's what gives you the pointy shapes, basically, like the head happened here. And if I decrease the rotation to 0, now you can push the points down like something like this. But I'm applying rotation and pushing slightly the pieces down, and you have this gradient where you can modify where the effect's happening. So once you're happy with that, all you have to do is to come in here and save the disk, because this deformation is being used for all of these layers as collision for the grains, the RBD, and the pyro. Speaking of grains, that's coming from a third output. All I have to do is select the grains, null, coming to point velocities, and this is where you can reshape the way that you have your velocity. All you have to do is to visualize velocity first, and you get this. You have a direction. Right now I'm adding a direction on the Y and on the Z, so pieces just have some velocity towards this way, and you have minimum and maximum. You have offset, frequency, and I'm adding reflection. If you visualize the velocity, I'm adding reflection from the points, from the bullets. So you expect to have some velocity towards this way. That's what is reflection responsible for, and I am multiplying this by a remapped or refit values of the Y. So we are applying more reflection towards the top and less reflection towards the base area. So instead of having something like this, we are just applying towards this area, and slight amount is more than enough. And you can also add some reflection noise for this. Once you are cool with that, all you have to do is to turn off visualize velocity, come to vellum properties, enable the sim, reset, and you'll get your simulation. Let's first disable the velocity visualizer, and you'll get something like this. So let's cache this. I already done that. Let's make sure this is the same cache. It is. And all I have to do now is to come to post sim. I have removed the clustered points because you get some clustered points that lives in here. It looks a bit weird. And for the color, you can choose between custom color and use grand color. And you can choose basically a map. You can visualize this texture from here. And now we are taking the color from this texture. So you get something like this. And this color, what's gonna be used inside of the pyro. So the smoke will be the same color as your grains, basically. Coming to the RBD, that's coming from the fourth output, And it's very, very basic. All you have to do is to isolate points for RBD. And visualize instance. You can increase or decrease how many points you want this to be instanced. We can instance geometry on it and be used inside of the rigid body solver. So less is better because you don't want to have so many of this. Too much of this will not be as efficient. So you can we can visualize instance, and you have maximum B scale and minimum B scale. Have a seed, and you can add angular velocity, so that will make the pieces rotate. And you can add also interior detail. And once you are ready, all you have to do is to enable the sim and save the disk. And I already done that. But I was using way more points in my old cache, so I get this simulation. And for the last output, I have the pyro. Come to pyro. We have the PopSim sourcing, and we need to isolate layers because we have 3 layers: main, secondary, and trails. And each one correspond with its layer. Like layer 0 is our main, layer 1, which is our secondary, layer 3 is trails, and layer 4 you are going to visualize the 3 layers together, which are these ones. So let me show you each one. The layer 0 is basically all of the grains that are clustered. You can give it it has a maximum life, and you can isolate by speed. I'm using B scale by in age, so it has a minimum and maximum B scale. So at the beginning of their life, they have a bigger B scale, and by the end they are dying and fading out. And you can add divergence for each layer, basically. So once you are happy with the settings, all you have to do is to uncheck ISO layer and come to pyro. You have the voxel size, minimum substeps, maximum substeps, anticipation for the fields, for the density field, and you have some settings for the color if you want to add sharpening. And for the sourcing, you've got density, temperature, velocity, divergence, and CD. Now for the shape, you got wind, disturbance, turbulence, and volume velocity. If you select this pyro, and if you visualize volume velocity, you can visualize, and now I'm adding curl noise, and you can add different, and you can play with the noise settings for the curl noise. And all you have to do is to uncheck visualize volume velocity and press play. And you will get your pyro simulation. I believe I have already cached this, but inside of the pyro pick you can add fire, which will make like a muzzle flash that happens. You can turn this on and off. And the post process, we are converting to VDB, combined volumes, converted 16-bit floats, and we are resembling the velocity field. So all you have to do is to come to cache under main, and you cache this. So it's gonna be our main. You give it a start and end, and you press save to disk. So this is what we end up. This is a cache for the first layer. So let's make the other two. And the other 2 layers are almost the same, except sourcing So to switch to the second layer, come to ISO layer, and I'm using layer 1, which is the secondary, and this is the exact opposite of the first one. Like, this is a clustered points, these are the loose points, and I'm giving them a maximum life, a longer maximum life than more than the main one. That's the main difference, and I'm increasing divergence to 5. Once you are happy with the settings, all you have to do is to come to ISO layer and disable the visualization. That will turn to pyro, and I will take this copy from the main, come to secondary, and I will change this to secondary. Alright, so this is the second layer, and let's jump to the third one, our trails. Come to PopSim sourcing, ISO layer, second one, which is a trails, sourcing amount, how many I want to source from this. So let's see, let's press play, and we get this. I don't think it's too much, so I will use it. All I have to do is to turn off the visualization. Now this is the third layer. Come to trails, 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 and save the disk. So this is the trails layer. So to view all the layers together, I have to check on view all, and these are all the 3 layers combined together. Cache all of the smoke layers in one cache. You can check use all layers and cache it in either one of these, so it will cache the 3 layers together. And you have noticed that it's supporting the vehicle, so I do have this vehicle here, and all I have to do is to change this to this vehicle and visualizing the points, and not character, vehicle, visualizing points, and make sure that you are selecting front wheels and back wheels. That's it. Selecting front wheels and back wheels. Select the bullets, and you get a representation, a more accurate representation for the car, for the vehicle, than the character. That's it, and everything will carry on the same as the character. And I will encourage you to go inside of here and check out how things are being done. It's really cool, and I think this might be beneficial for someone. So experiment with this. I've tried to label everything that I can, so it makes it easy for you to understand what's happening. And hope you like it, and tell me what you think.